Hi everybody. So what I'm going to be showing you today is how to calculate residuals, line of best fit, those sorts of things through Desmos. We're going to be using example 3 in chapter 4, this Old Faithful one. So first thing I got to do is enter the data. To do that, we click this plus sign, add item, and we want a table. So we click table. Then I'm going to enter all my x values followed by all my y values. And 60. Alright, so we have all the data. Now none of it's showing up because we don't have a good window. So to change the window, we move over to the graph settings. We're going to change our x-axis and y-axis. So our lowest x is 2. So I'm just going to go to -1. And my highest x is about 4. So I'm going to go to about 8 just to give me plenty of room to look at everything. My lowest y is 58, so I'll make this 50. Oops. And my highest x is 85, so I'll make this about 100. You can have a different window, but this seems to work pretty good. To click off, you just click the wrench again, it goes away. So now I want to figure out, I want to do all my linear regression. To do that, we type in y1, and it automatically will sub-element this. We hit the tilde button, the little squiggly button to the left of the 1 on your mouse, on your keyboard. M, x1, plus b. Now what this does is this says, alright, let's make a linear function in slope-intercept form with x as my input and y as my output from the table, and they'll do some calculations to figure out what your slope and y-intercept should be. This is saying my slope is about 11.99 and my y-intercept is about 35. My correlation coefficient is 0.979. That's very close to 1 and it's positive, so that suggests this has a positive correlation. If we take a look at our graph, our line is pretty strongly, it goes through most of the points and is about the same above and below. Now to calculate the residuals, you click this button here. Residuals, E1, you click plot. And up here, all of a sudden, it will list in the table. Let me see if I can move this over. Yeah. List in the table your residuals. So you got 1, 2, 3, 4 negatives, 1, 2, 3, 4 positive. That seems pretty good. But we can't see our residuals because look at these numbers. They're numbers between -3 and 3. So what I'm going to do is I'm going to change my graph to just look at these. Now to do that, I have the same input because they're going to graph 2, 0.9, 3.7, 3.5. So my x is fine. My y has got to change. I'm going to go from -5 to +5. And we click the wrench to go off of it. Now if we look at this, we have about the same amount of points above and below. This one's almost on the line. We got 4 below, 4 above. That looks pretty good. The numbers aren't too far away. Go from 5 to -5. What that means is, like, this point here means our equation is a little bit low. It means the actual data value is higher than our equation. A point down here means the actual data value is lower than our equation. That's kind of all this means. So this is pretty good. We're pretty happy with this. All right. If we go back for a moment and interpret things, all right, the slope is 11.99. The y-intercept is 35. So we go back to this example. Interpret the slope and the y-intercept. So the slope would be telling us like how often this happens. So like what the duration is based on how long you wait. So on average, the duration is going to be about 12. Our y-intercept of 35 tells us that the time is usually about 35 minutes until the next eruption. Yeah, so hopefully you found that useful. You can play this as much as you want. You can pause it, stop, move along with the video, whatever you need. I'll see you in class. Bye-bye.